What precisely lies at the edge of the recognizable universe? Indeed, this has stayed a secret for a really long time, powering interest and theory among researchers and devotees the same. Nonetheless, the James Webb Space Telescope holds the way to divulging this enormous secret. With its strong focal points looking further into space, it has as of late made a historic declaration of what lies at the edge of the discernible universe. At the point when we discuss the edge of the universe, understanding the idea of the discernible universe is fundamental. The perceptible universe incorporates all that we can see, measure, and study from Earth or our space-based telescopes and exploratory tests right now. It comprises of stars, systems, and other heavenly articles that are inside our observational reach. Thus, what's the distinction between the universe with a capital U and the noticeable universe? In straightforward terms, the noticeable universe is only a little part of the whole universe that we can study and understand. While the total size and state of the whole universe are obscure, there is an expected width of the recognizable universe which is around 93 billion light-years. Presently, a light-year is a unit of distance that light goes in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. Thus, the width of the noticeable universe, 93 billion light-years, is an incredibly immense field traversing roughly 546.84 billion trillion miles or 878.58 billion trillion kilometers, displaying the awesome scale of our vast environmental elements that is hard to try and appreciate. Be that as it may, for what reason is the universe so unbelievably huge? The response lies in its starting points. The theory of how things came to be lets us know that roughly 13.8 a long time back, the universe was brought into the world in a strong blast. This touchy occasion set off a quick development, and from that point forward, the universe has been extending at an undeniably quicker pace, driven by mysterious powers like dim energy. As the universe extended, particles of issue began grouping together because of the power of gravity, framing remarkable designs like stars, systems, and ultimately even planets like our adored Earth. Over innumerable years, these enormous designs became bigger and more multifaceted, prompting the exceptional variety of items and peculiarities that we notice all through the universe today. Notwithstanding the endlessness of the universe, it is dominatingly void. To put it in context, on the off chance that we downsized our whole nearby planet group to the size of a quarter, the closest star would in any case be the distance of 2 soccer fields away. Also, this is simply inside our smoothway cosmic system, which is one among billions in the recognizable universe. You might ponder, for what reason might we at any point see the whole universe? There are 2 factors that make sense of this. The principal reason is that light requires some investment to go through space. At the point when we look at far-off objects in the universe, we're really noticing them as they were in the past. The farther away an article is, the more its light has taken to contact us. Along these lines, by noticing far-off cosmic systems, we're basically looking back in time, disentangling the historical backdrop of our universe. The subsequent explanation is the universe's extension. Envision spots on the outer layer of a blowing-up expand. As the inflatable extends, the specks create some distance from one another. The equivalent standard applies to the universe, where systems are floating separated as space itself extends. This extension makes the light from far-off objects become extended as well, moving towards longer frequencies, which we see as redshift. At last, a few objects will move past our observational reach as they retreat past a specific distance. Considering these elements, it's not shocking that we haven't seen the whole universe yet. Presently, the idea of the edge of the universe is a marvelous subject that has interested researchers, savants, and masterminds for a very long time. We have a wide range of speculations about what lies past, yet reality stays slippery. Nonetheless, there are 3 speculations that stick out. The principal hypothesis is that the universe continues always, forever. This hypothesis depends on the cosmological standard, which expresses that the universe is isotropic, meaning that it appears to be identical toward each path. Assuming this guideline turns out as expected, that's what it suggests the universe extends on perpetually without a limit. That's what the subsequent hypothesis recommends the universe is limited. However, it doesn't have a reasonable edge by the same token. This implies it's comparable to a monster ball, and on the off chance that you continue onward toward any path, you'll ultimately circle back to where you began. The third hypothesis is the multiverse hypothesis, which recommends that our universe is only one of many. Envision a lot of equal universes, each with its own arrangement of rules and properties. These universes could be totally different from one another or, on the other hand, some way or another associated. In this way, we've discussed ideas encompassing the edge of the universe by checking assorted speculations out. Presently, let us direct our concentration toward a wonderful device that holds the possibility to reveal insight on these secrets. The James Webb Space Telescope, JWST. This inconceivable telescope permits us to look far back in time and find unforeseen objects from the beginning of the universe. The JWST, with its high-level abilities, has empowered cosmologists to peer back into the beginning of the universe. Also, prepare to have your mind blown. They've coincidentally found something unforeseen. In a new report distributed in the diary Nature, the JWST found 6 gigantic universes that existed between 500 million and 700 million years after the enormous detonation. Analysts were just hoping to track down little, recently framed systems. However, the JWST got them unsuspecting. These worlds are way bigger than anybody at any point envisioned, testing what we assumed we had some awareness of the early universe. Yet, that's not all. Researchers additionally found something incredible. These universes are basically as experienced as our 13-billion-year-old Smoothway universe. The mass of stars inside every one of these items adds up to a few billion times bigger than that of our Sun, as per the examination. One of them specifically may be, however, much 100 billion times our Sun's mass. For correlation, the Smoothway contains a mass of stars comparable to approximately 60 billion suns. This telescope has an exceptional power. It can see things that are imperceptible to our eyes by utilizing infrared light. It gets the weak shine from old stars and cosmic systems that have been around for a very long time. This implies the JWST can in a real sense take us back in time, giving a brief look at what the universe seemed to be around 13.5 a long time back. Presently, here's where it gets truly fascinating. The universe is assessed to be around 13.7 billion years of age. So this revelation has flipped around things. It resembles revising the set of experiences books. These massive worlds, nicknamed universe breakers, have researchers scratching their heads. They challenge the vast majority of the models we had for early worlds. We used to think universes began as little billows of stars and residue, step by step developing over the long run. Indeed, these universe breakers demonstrated us wrong. At the point when the Webb information and high-goal photographs from the telescope opened up in July 2022, specialists were blown away. They were shocked when they saw these worlds as huge marks of light, questioning their own translation of the information. The abrupt appearance of these enormous items, as though they needed to be found, shocked everybody. By utilizing spectroscopic procedures to examine light across various frequencies, researchers can uncover important data about these universes, like their structure, size, and distance from Earth. Captivating that this historic revelation wasn't indeed even on the first spot on the list of things researchers expected to find with the James Webb Telescope. It surpassed all assumptions and unfurled much faster than expected. There's even a likelihood that a portion of the items found utilizing Webb information might be something completely unique. While most are reasonable universes, quite possibly a couple could be covered up supermassive dark openings. Here is the charming part. The known mass of stars known to mankind is presently accepted to really depend on multiple times more than we recently suspected. This revelation is still incredible, regardless of whether we think about just 50% of the example. In the interim, utilizing the strong James Webb Space Telescope, JWST, a global group of cosmologists too made an unimaginable disclosure. They've found the most seasoned and farthest cosmic systems at any point affirmed. These systems return us to when the universe was only a small portion of its current age, less than 400 million years after the huge explosion. The light from these universes came to us more than 13 point for a long time back, as recognized by the telescope. Like the early perceptions made by the Hubble Space Telescope, the underlying pictures caught by the JWST uncovered various expected universes. Presently, through careful spectroscopic perceptions, stargazers have affirmed 4 of these articles, permitting them not exclusively to concentrate on the actual properties of the worlds yet in addition to decide their distances precisely. To decide a universe's distance, cosmologists ascertain its redshift. You might be pondering, what is redshift? All things considered, it turns out that as the universe grows, objects seem to get away from us, causing their light to stretch and move toward longer, redder frequencies, a peculiarity known as the Doppler impact. While redshift evaluations can be gotten from photographs taken through different channels, spectroscopy is the favored strategy for acquiring exact estimations, as it separates the item's light into its constituent frequencies. The new revelations center around for universes with redshifts more noteworthy than 10. This implies they are really far away. The Hubble Space Telescope recently spotted 2 of these universes, and their redshifts were affirmed to be 10.38 and 11.58. Besides, the JWST Advanced Profound Extragalactic Survey, JADES, is an aggressive program that has been dispensed more than a month of the telescope's time. Its goal is to give a remarkable top-to-bottom look into the early universe. In 2015, a consortium of instrument groups proposed this venture, shaping a worldwide organization known as JADES, involving in excess of 80 cosmologists, also researchers from 10 unique countries. Starting with NIRCam, the JADES program devoted throughout 10 days of mission time to noticing a little district of the sky, including the Hubble Ultra-Profound Field. For north of 20 years, cosmologists have been investigating this locale utilizing different huge telescopes. By concentrating on the field in 9 different infrared frequency groups, the JADES group made an exceptional disclosure, almost 100,000 far-off systems, every billions of light-years away. Then, utilizing the NIRSpec spectrograph, the researchers gathered light from 250 weak worlds during a 3-day noticing period. This empowered them to uncover the attributes of the gas and stars inside these universes and get exact redshift values. With these estimations, stargazers can decide the inborn brilliance of the worlds and gauge the quantity of stars they contain. This considers a far-reaching assessment of universe arrangement after some time, even without direct information on their initial development stages. Concentrating on systems can be just about as trying as grasping people. The early ages of stars significantly affect the fate of universes, similar as how our initial encounters shape our lives. This is an uncommon time in history when the groundbreaking abilities of the Webb telescope are addressing various inquiries about cosmic systems. NASA's Profound Space Observatory Telescope is altering our comprehension of the universe and uncovering a mother lode of new disclosures. The James Webb Space Telescope, Webb, a trailblazer in logical exploration, is furnishing us with surprising experiences into universes, planets, stars, and other enrapturing, inestimable peculiarities. Sent off in December 2021 also, expected to work for quite some time, Webb is simply leaving on its inestimable experience, outperforming the norms set by its ancestor, the Hubble Space Telescope. Webb has caught the creative mind of researchers and the public the same, moving an influx of logical excitement. Individuals overall are anxiously altering the telescope's crude information. It is stunning to share photographs and acquiring new points of view. Following an impeccable sending process, Webb shocked us with its underlying photos in mid-July, allowing us an extraordinary perspective on our universe's hoard angles. With the assistance of its high-level infrared telescope, we can investigate the farthest systems in momentous detail and friend into the profundities of the past. Not long after going online in late June 2022, Webb's strong instruments began uncovering large number of beforehand obscure worlds, more seasoned and more far off than any other time in recent memory envisioned. Besides, the telescope's abilities empower researchers to accumulate bountiful light from divine articles. For example, exoplanets and infant stars, disclosing their arrangements and following their directions through space. This abundance of information is now uncovering mind-boggling insights concerning the barometrical organizations of planets found many light years from Earth, indicating their expected livability. Yet, in addition to that, by breaking down faint hints of light from the universe's earliest stages, the James Webb Space Telescope has possibly recognized the most established dark opening at any point noticed. This supermassive dark opening, with a mass 9 million times that of the Sun, lives at the center of a youthful system that framed 570 million years after the birth of the universe. On account of Webb's strong cameras, Equipped for looking back so as to the universe's earliest minutes, this great revelation offers experiences into the enormous daybreak when various dark openings filled in size throughout the span of 1 billion years following the enormous detonation. The beginnings and expansion of these confounding, inestimable elements remain secrets that puzzle cosmologists. A portion of these monstrous grandiose interruptions transmit light detectable by telescopes, made by the contact of materials spiraling into their gravitational void. These articles, known as dynamic cosmic cores (AGN), supermassive dark openings or quasars, are billions of times more massive than the Sun, emanating serious explosions of light, trillions of times more brilliant than the most splendid stars. They address the most limit type of AGN. As researchers adventure further into the universe, they can catch light from more far-off sources, giving looks into prior phases of the universe. The James Webb Space Telescope, JWST, utilizes its mid-infrared instrument and close infrared camera to check the sky, looking for dark openings. Its inherent spectrographs then independent the light range into various frequencies, permitting researchers to dissect the information. During their examinations, researchers made a vital revelation. The warmed material encompassing a dark opening produced faint hints of radiation across the universe. By investigating these sensitive flickers from the universe's outset, they identified a startling flood among the frequencies installed inside the light, giving significant bits of knowledge into the inestimable cycles at play. The rapid appearance of dark openings in our young universe stays a secret. Researchers proceed with their quest for a lot more youthful early-stage dark openings, which are accepted to have shaped just after the huge explosion or perhaps considerably prior. Nonetheless, these subtle articles have, however, to be found. In the interim, two primary clarifications exist for the overflow of dark openings in the current universe. One chance is that they are remainders of monstrous stars that shaped substantially more quickly than the stars we notice today. On the other hand, it's proposed that thick billows of gas unexpectedly imploded to shape these confounding singularities in spacetime. A more likely situation involves a populous 3-star, a theoretical class of stars that arisen around 200 million years after the huge explosion, fundamentally made out of hydrogen and helium. Such a star would have detonated, abandoning a dark opening. Thusly, the dark opening would have filled in size by quickly gathering matter at a rate surpassing security. Researchers are teaming up with the group behind the advancement of MIRI to concentrate on the faraway system's light and look for extra signs about the development of the puzzling dark opening at its focus. Researchers have additionally inspected the beginning phases of the universe and noticed the development of a protobunch involving 7 collaborating systems. This bunch, found by the Hubble Space Telescope, is the most far-off world bunch recognized by scientists. Recreations propose it will ultimately become one of the most seasoned and biggest realized cosmic system groups in the universe, with a mass almost multiple times more prominent than that of our smoothway world. While the underlying disclosure of these universes was made by the Hubble Space Telescope, it missing the mark on a version to definitively measure the distances between them, in spite of their arrangement along a similar view. Envision being high above Los Angeles and looking through a telescope. You could see Phoenix, Dallas, and Atlanta, however you couldn't have the foggiest idea about the exact distances isolating them. Isn't that so? Be that as it may, on account of the James Webb Telescope, we got to see a much more clear picture. These sorts of groups, as per researchers, are very uncommon and challenging to find. In spite of the fact that it's improbable that the JWST will find another extraordinary framework like this, the future Nancy Elegance Roman Space Telescope, set to send off in mid-2027, will improve our capacity to distinguish system bunches in the early universe. Its wide region review capacities will outperform the JWST by north of 100 times. Back to the disclosures made by the JWST, in the 1990s cosmologists made earth-shattering exoplanet revelations because of this progressive telescope. We currently know of more than 3,000 extrasolar planets, albeit just 12 have been straightforwardly shot. Most exoplanets are far off to such an extent that we can notice them when they travel in front of their host stars, causing a slight darkening of light. Notwithstanding, the JWST has changed the game. Utilizing the telescope's coronagraphs, joined with its cameras, channels, and other gear, researchers can straightforwardly notice exoplanets. In 2017, the Circle Consortium made a critical revelation by distinguishing a planet called HIP 65426b utilizing the spectropolarimetric high-differentiation exoplanet exploration instrument. HIP 65426b is an exoplanet that circles its half-star, HIP 65426. In September 2022, it acquired further consideration as the first exoplanet to be straightforwardly seen by the James Webb Space Telescope. What makes this planet especially fascinating is its novel qualities joined with the momentous awareness of the James Webb Telescope, which takes into consideration more straightforward perception. In contrast to some other planet in our nearby planet group, HIP 65426b is arranged a good ways off from its host star that is multiple times more noteworthy than the distance between our Sun and Earth. To give you some point of view, Pluto is only multiple times farther from the Sun than Earth. Presently, envision an exoplanet that is a titanic gas Goliath, multiple times the size of Jupiter. Despite the fact that the apparition universe is slippery in the evening sky, its splendor is as yet noticeable, particularly when caught by Webb's infrared camera. When we take a gander at the cosmic system known as M74, we're blessed to receive a dazzling perspective on its lovely twisting shape and the scattering of stars. The world's brilliant focus brings forth arms that stretch outwards. Hubble's optical perspective on this item highlights its quality.